Right, good day and welcome back to Everything Mathematics. And today we're going to be looking at our fifth and final rule. Yes, I call it final because at the ending of the day, Rule 5 and Rule 6, to be honest, they are very similar. The only difference I notice a lot of textbook does nowadays is like they just make each sign a different rule. And I see why, because I could tell you changing a sign in a question, believe me, could cause significant difference in your result. But I will relate to both of them as rule 5. So if you want, you could put it as rule 5/6, because the difference, to be honest, is just the change of sign. And I'll explain as I will relate as I explain, right? Good. So rule 5 states this. Rule 5 states that if you have C over, again, let's say we have some constant B plus, let's say we have a root. So rule 5 is very similar to rule 6, not rule 6, rule 3, when we learned about rationalizing. So if we have something like this, A, B, root, let's call it what? Root X. Let's make it root X. If we have something like this, to rationalize this whole process, all we do is basically C over B plus root X, and we are multiplying that by the reciprocal of the bottom. And the reciprocal simply means that you change the positive sign into a negative. So that will be B minus root X. You could put that at the bottom, and for now, I'm going to represent it like a fraction. And at the top, you have B minus root X. This is basically rule 5. And of course, from here, you basically, it's like you're doing a quadratic expansion. You just distribute. So the C multiplied by the B, the C will be multiplied by the root X. The B multiplied by B, the B multiplied by root X, and blah, 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 blah. When you do that, what will eventually happen is that you will be getting rid of the root, the square root at the bottom. And remember, when we look at rule 3, we explicitly said that when dealing with surds, for whatever reason, in fact, there's a reason, but I don't want to go into that. But we don't leave a square root as a denominator. So as a result, the process of getting rid of a square root in the denominator position, which is at the bottom of the fraction, we do what we call rationalizing. If it's a single variable that we have or a single constant that we have, all we do is multiply that constant by that constant itself. So if you go back to rule 3, I don't want to go back to it, but we did it last week Friday, you would notice that I could always try and remember if I could put a tag here, a cab, whatever they just call that thing. So I could maybe click to it more direct. But yes, the whole idea is that you multiply it by that. So let's do some examples. The algebra here would not make much sense if you're not algebraically versed. Well, guess what? I'll do it anyway. I'll do it anyway. Right. So if we do this algebraically, just for us to see the concept, the whole idea is that we multiply the C by this, and then we multiply the C by that. Then we do the same thing at the bottom, but below is like we have a quadratic. So at the top, we will end up with something like CB minus C root X. That's when I distribute the top. At the bottom, you get something more interesting. B times B would give us B squared. Then b times minus root x will get minus b root x. Don't let the algebra throw you off. Then we have positive root x by b, so that will be positive b root x, and positive root by that negative root. The roots will cancel each other and we'll just stay with a negative x. The root cancel each other, and then we just say whatever that is. We don't know what it will be, but yeah, it will. In this case, it will be x. And a negative times a positive is a negative, so we have negative. And notice what is taking place here. This will always be a scenario in which you see this here will cancel this here, thus getting rid of what was under the square root. And that will give us with a final answer of CB minus C root X, all divided by B squared minus X. Notice now that as a denominator, or in the denominator position, there is no square root. And that's what this process does. It simply gets rid of whatever square root will be at the bottom. So again, let me just explain the rule briefly. Whatever is at the denominator, you just multiply it by the reciprocal of itself. And how do you get the reciprocal? Just change the sign. Whatever is it, just keep it the same, but change the sign. And once you change the sign, so if it's negative, if it's positive, it becomes negative. If it's negative, you multiply by the positive. And this is where rule 5 and rule 6 play with each other. In rule 5, we taught that if it's positive, you convert it to a negative. And rule 6 says the same thing, but it's just the opposite. So if it's negative, you multiply by the positive. So that's why, as I said, in rule 5 and rule 6 is one and the same. It's just that you're changing the different sign. And yes, once you change the sign, then it's a matter of just doing your algebra. You're simplifying. That's all that's happening from here, simplification. So let's see if we could do a few examples. I mean, just talking it doesn't show much, but when you do some, hopefully, you get it better. So here we have for our first example. Let's say we have 5 all divided by 4 plus root 4. Good. And according to the rule again, I multiply this by the reciprocal. So all I have to do, if I simplify this, well, you wouldn't be told to simplify. You will be told to rationalize. To rationalize this, you multiply by the reciprocal. So instead of 4 plus root 4, oh no, look at that. Let me change this root. Well, no. Let me change it. I didn't even notice this. Let me not put root 4. Let me put root 2. Because root 4 could simply solve. If you have, okay, let me just go back to for those that may not notice. Yes, if I have root 4 here, I ain't going through that whole process. You just open your eyes and realize that root 4 is the same thing as just 2. So this would have simply been 5/6. So yes, in the future, be cautious for that. Sometimes, well, I don't know if you could get a disguised question like that. But yes, I just make up a random question and I didn't even pay attention to that. But yes, let me make it root 2 instead because root 4 would not make sense. And mind you, if you rationalize root 4, you will get the same thing, but you'll just take longer. It's like you're just taking the long cut when you could have taken a shortcut. So let me make it root 2 to be more practical. Right. So yes, if I have this, I'm multiplying by the reciprocal. So that will be 4 minus root 2. Yes, that's the reciprocal of 4 plus root 2, just the negative of it. And at the top, you multiply by the same. Whatever you multiply the bottom with, you multiply the top by the same thing. And once you have this, then it's a matter of simplifying. I will do this in a different way just so that you see what is taking place. When you have it like this, the essence is this. 5 times 4 minus root 2. That will be at the numerator. And in the denominator, we'll have something like 4 plus root 2 multiplied by 4 minus root 2. I'm doing it like this so that you will see what is really taking place. So here's like we have almost like a binomial expansion sort of, or let me say the distributive law. That might be even better. It's like the distributive law. So here's like this times this times that. You multiply the 5 by each term. It wouldn't always be a single term, by the way. I have another one later on for today that have a different term. So we have 5 times this and 5 times that. And at the bottom, we will have something like we're multiplying 4 times 4. So it's like, let me go back to quadratic equation. Remember when we did a quadratic equation and we have x plus 2, and then we might have x minus 3? This is the same thing that is taking place here, but with surds. So, you know, is the x times this, then the x times that, then the 2 times this, then the 2 times that. And then you simplify, you know. If we were dealing with a quadratic, we had, okay, x times x, that will give us x squared. X times minus 3, that will give us minus 3x. 2 times x, that will give us 2x. And 2 times minus 3, that will give us minus 6. And then we simplify here, and we end up with something like x squared minus 3 plus 2, that's minus x minus 6. So that's what we would end up with if we were doing it a quadratic. But here we're not doing it quadratic, we're doing the surds. But the concept, the process is the same as what I just did there. So at the top, 5 times 4, that will give us 20, and 5 times negative root 2, that will give us negative 5 root 2. That's at the top. At the top. At the bottom now, see me well, 4 times 4, that will give me 16. Then I have 4 times negative root 2, that will be negative 4 root 2. Good? So that's that with the 4. I'm done with that 4 there. Let's try it with the other one now. So now we have root 2, positive root 2 times 4, that will be positive 4 root 2. And then positive root 2 times negative root 2, that will be negative 2. Good. In essence, it's like we have 2 times 2. Okay, let me put it this way. For those who cannot see the negative 2, think about it this way. So it's like we have a positive root 2. You're multiplying that by a negative root 2. And if we go back to the same rule that we had earlier, let me take out the signs for now. Let me take out the signs for now, because I don't want to throw you off with the sign. So ignore the signs. If we go back to rule 1, it's almost as if we're doing the reverse. So 2 times 2 was the same as root 2 times 2. Remember that? And then 2 times 2 would be the same as root 4. And root 4 is the same as 2. And then you respect the sign. It's a negative times a positive. Negative times a positive is a negative. So that will end up with a negative 2. So in essence, you don't have to go through this whole process. But what you need to remember, and this will always be the case, whenever you multiply two roots that have the same constant inside it, you will always get back just the constant. Always. So root 2 multiplied by root 2 will just give us 2. If it was root 5 multiplied by root 5, guess what? We will get 5. Root 7 multiplied by root 7, we will just get 7. Once what's under the root is the same and you multiply by each other, you will always get back the same constant. And it makes sense because when you really think of it, it's like when you multiply a number by itself, you're getting the square, you're getting a perfect square. So of course, when you find the square root of a perfect square, you get back the same number. So yeah, that will always be true. You could look at it that way. Of course, if you want to take the long way and go and prove it, that's fine. But yeah, sometimes you should know because they do ask sometimes to prove it based on the level of exam that you're doing. Right, so yes, that's how we reach here. So notice here now that minus 4 root 2 and positive 4 root 2 could cancel each other to 0. And that would leave us with, let's see what remains. That would leave us with, taking my answer to the top, that will leave us with 20 minus 5 root 2, and we're dividing this by 16 minus 2. 16 minus 2, I think we could easily see that. That's the same as 14. And this is as far as we could go. Well, let me not say that. I'll take that back. We could simplify this further. If you want, since you have one constant as a denominator, you could separate the fractions. So this is the same as, and you could do that in cases where it could break down, like in this case you could. This is the same as 20 over 14 minus 5 root 2 over 14. And this could break down, we could use 2. 2 could go into 10, sorry, 2 could go into 20, 10 times, 2 could go into 14, 7 times, minus 5 root 2, which is the lowest it could go, over 14. And you could convert this into an improper fraction, but I don't know, that's up to you. I'll leave it there. Good. So yes, I will stop at this one for today. But in tomorrow's video, because I don't even know how long I'll take there, but I feel like I'll take a while. In tomorrow's video, what I will do this same rule, but I want to show you other questions that could come with rationalizing. So tomorrow I'll just go straight into the applying different questions. And then after we're gonna see how it could vary and how the rules could apply. So yes, of course, I trust this was clear enough, but if not, of course, leave a question in the comment section. And of course, feel free to always subscribe if you haven't as yet, like this video and share with your classmates. And until the next time, you do take care.